Hello again YouTube, and this again is Amy version number 2. All completely built except for missing the relay. So I've got a new Pico. I've been waiting ages for these Picos to come in. I must have been waiting for about 2 months for them to arrive. But anyway, they've arrived now, and I want to modify this one because I kept blowing these up, and I think there's a design flaw with this DC-DC converter. Not sure exactly why, but this current application, that DC-DC converter chip keeps blowing. So what I'm going to do is I'm going to remove that diode there, and that will disconnect power to the DC-DC converter on the board. I'll use a pointy stick. So remove that diode, because that's your input here. So there's going to be 5 volts on here. We're then going to connect a linear regulator between the 5 volt, the ground, and the 3.3 volt, which is here. And because that diode's not going to be in place, this DC converter won't be powered up. It'll just be a linear regulator going across there. And then hopefully that will fix the blowing up problem. Because I've been trialing that on this, and it's been running for ages and ages. As you can see down here, there's the linear regulator. And it's been working fine, and there's been no smoking. So I'm now going to try it again on a proper board with another Pico and see what happens. So that's the diode removed, and the diode is in fact here on the tweezers, and that was just sitting there. So that's now off, and the linear regulator I'm going to be using is this one, and that's the RS part number, and that's the true part number. So I'll be fitting that across these input supply, ground, and then the 3.3. So that's the linear regulator fitted, and I'll try to make it a bit neat and lay it flat on the board. Now, of course, this isn't production ready. This is still a prototype board. So what I could do in the final version, actually have that as a through-hole device, or even doesn't have to be a through-hole part. It could be a surface mount part. Focus. There you go. It could be a surface mount part somewhere around here, going actually to the pads, and then you just remove that diode and fit it there. So that's the current plan. We'll power it up and see if that works. All right, I'll power this up live on video just in case it explodes, because that'd be a laugh, wouldn't it? That's a bad sign. What's going on? It isn't drawing any current. Oh. Right, false alarm. I think that was a bad connection. But it's working now. So, got a red light on. If I increase the voltage, then we should get a blue, green. There you go, there's a blue light. As we go up, should get a green light. There you go, green light. And as we go down, it'll become a dim red light. Now I don't have the relay connected at the moment, but that will be kicking in and out as the voltage changes. But that appears to be working. I'll leave that powered up and power it up for a couple of days, just to make sure it's stable, and I'll fit the relay as well. But we're getting there. So that's how I fixed the DC-DC converter problem on the Raspberry Pi Pico. I believe there is an issue with the board. I don't know if you draw too much current from it or whatever, but you can easily smoke the DC-DC converter. I've done a few now. So just a word of caution, and that's how I fixed it on this board, by changing it for a linear regulator. And it doesn't get warm at all, because again the current consumption right now is 9 milliamps, and that's with the LED burning. So hope you found that informative, and I shall see you again next time. Bye for now.